Welcome back for another exciting adventure solving problems with the experimental gas laws. Here we go, just a refresher. You've seen these before. Keep drilling it, kids. Keep drilling it. First one's for constant pressure. The second one there is for constant temperature. Get your head around that those are only true for those certain caveats. And then combining them, we get this general one, which we can apply pretty much anywhere. Okay, so that's that. So we did the true or falses before, so we're not going to do them again. You keep reading, don't just read the textbook we're given, go to hyperphysics, read other sources, Wikipedia even. Wikipedia is a very reputable source these days, it's checked all the time. Right, let's move on. So I sent you these 4 questions. Now question 4, I'm going to go through it in one whole video because it's a really high level question, that is. It's quite a tricky one, which stumps a lot of students. We've done 1 and 2, applying Boyle's and the pressure law. The third one was applying Charles' law, and the third question, like this, we've got a fixed volume of gas at 15 degrees with this volume, it's heated without a change of pressure. So we're talking about constant pressure, Charles's law, constant pressure. So we're just looking at temperature and volume. Let's get the magic camera up. So, okay, Izzy, let's get busy. There we go, there's the magic camera, good. So let's have a think. Let's draw a picture. We've got a fixed mass of gas. Let's imagine we've got a balloon of gas. It's in some sort of balloon. There we go. And that has a volume of 0.085 meters cubed. Easy peasy. We'll call that V1. Okay. And we know the gas was heated to 55 degrees. We know that the gas, when heated to 55 without change of pressure, calculate new volume of the gas. Okay, I'm missing some information here. What am I doing wrong? If I miss some information here, if I cut off half the question there, kids. Oh no, ignore. I'm having a senior moment. It's quite late in the day now. It's actually 2 o'clock and I've been at it all day. There we go. Right, let's move on. So initially the temperature of the gas was 15 degrees C, right? Don't fall for that one. Read it in Kelvin. So I had 273, 283, 283. That makes 288 Kelvin, okay? That's the actual, and we'll call that T1. Constant pressure, so P1 is the same as P2, and the whole thing expands to make some new volume, which we don't know. But we do know that the temperature is 55 degrees C. Don't fall for it. Don't fall. The number of kids that lose exam marks every year because sticking that into the sums, it has to be absolute temperature. And that one comes out to be 328 Kelvin. Okay. Good. Right, move on then. So what is our relationship? What is Charles's law? Charles's law says that V over T is constant if we have a constant pressure, which we have. So mathematically we can say V1 over T1 equals V2 over T2. Whoops, someone's trying to contact me. So V1 over T, and what we're looking for, we're looking for V2. So let's rearrange that. Let's say that V2 is equal to V1 over T1 multiplied by T2. Can we do the sums there? Yes, we can. V1 is 0.085 times by the temperature 2, which was 328, divided by the temperature T1, which was 288. I reckon we've got a solution there. Let's get out the calculator. 0.085 times by 328. Always press your equals button. Don't put your sums all on your calculator at once. Great way of making mistakes. Okay, so I've done the top row, that equals that. And then divide that answer by 288. That gives me an answer of 0.096897. Okay, here we go. Look. 3 decimal places, and that is in meters cubed, and that is indeed the correct answer. Now we know it's the correct answer because we're in the right sort of ballpark. I didn't mention it on the last question, but the first question, that the order of magnitude, we start off and the volume to start off with was 0.085, and then it increases to 0.097. Okay, so both volumes, that's volume 2, are in the same ballpark. Okay, draw a picture. It makes life ever so easy. Okay, especially when you're tired and you're making mistakes. Apart from that, yeah, always turn Celsius into Kelvin. This is the biggest points loss in this topic, students forgetting that little step there. So hope you enjoyed that. I'll be back with that really difficult problem in a bit, but before I do that, I think I really need a really strong cup of coffee. Okay, so enjoy, keep reading. Any problems, email me, you know my email. Okay, so toodaloo.